A consumer's demand for a particular good usually depends on his income, as well as the prices of both this good as well as all the other goods that he's considering. But when we graph demand curves, we can only let one economic variable change, either income or the price of the good we're looking at or the price of some other good, and then map out how the demand for the particular good we're interested in is changing as a result of a change in that economic variable. Thus, when we graph demand curves, we usually hold lots of other economic variables fixed and zero in on only one particular economic variable. In a two-good model, there are three economic variables that can affect the consumer's demand for a particular good: the person's income, the price of that good, as well as the price of the other good. We therefore have three different demand curves that we can graph: the income demand curve, the own price demand curve, and the cross price demand curve. In this graph, we'll illustrate the derivation of the income demand curve. Consider, for instance, the case of me and my wife in college. We had $100 a week to spend, and one of the goods we bought was boxes of pasta. Each box cost $4 a piece, so we could buy as many as 25 a week at $4 a box. Or we could spend our money on other goods, and we could purchase as much as $100 worth of other goods if we didn't buy any pasta. It turns out that we bought a lot of pasta, 10 boxes a week, which left us $60 for other goods consumption. Then my wife's business started taking off, and so instead of having $100 a week, we had $200 a week, an increase in our income of $100 that's represented here by the shift of the budget constraint to the new magenta constraint. And it turns out that as we got richer, we consumed less pasta, only 5 boxes a week instead of the previous 10, leaving us now with $180 for other goods consumption. Pasta, it turns out, was an inferior good for us. As our income went up, our pasta consumption fell. We can now transfer the information that's contained in bundles A and B of the top panel to a lower panel where we still have boxes of pasta on the horizontal axis, but now we put income instead of dollars worth of other consumption on the vertical axis. At bundle A, for instance, we have an income of $100. That's how the blue budget constraint arose. Therefore, bundle A on the lower panel will occur at a vertical height of 100. At bundle A in the top panel, we're consuming 10 boxes of pasta. Therefore, bundle A on the lower panel will also show 10 boxes of pasta. We can then read bundle A on the lower panel as saying that at an income level of $100, holding all else fixed, we decided to consume 10 boxes of pasta per week. Bundle B, on the other hand, lies on the magenta budget, which arose from a $200 income. Thus, bundle B will lie at a vertical height of $200 in the lower panel. At bundle B, we're consuming 5 boxes of pasta, which should also be shown on the lower panel as 5 boxes. Notice that since we haven't changed what's on the horizontal axis as we go from the top to the bottom panel, the bundles will occur at the same horizontal distance from the origin in both panels. On the vertical axis, however, we're measuring something different in the top panel than in the bottom panel. In the top panel, we show dollars worth of other consumption, whereas in the bottom panel we show the income level. By connecting bundles A and B in the lower panel, we can then estimate the income demand curve. In other words, the curve that shows how much pasta we buy for different income levels, holding all other things constant, in particular holding the prices of pasta and all other goods constant. The downward slope of this relationship arises from the fact that we've assumed that pasta is an inferior good. As income falls, we consume more of it. As income rises, we consume less of it. Next, consider our consumption of steak, which costs $10 a pound. At our original $100 income, we could therefore afford as much as 10 pounds of steak per week, or we could consume no steak and $100 worth of other consumption. our optimal choice was to buy 6 pounds of steak, leaving $40 for other goods consumption. If we really did buy 10 boxes of pasta with our $100 income as we illustrated in panel A, that would actually mean that pasta was the only other thing that we consumed, and dollars worth of other goods is actually dollars worth of pasta. Our increase in income to $200 then again causes a parallel shift in our budget constraint. And if pasta and steak is really all we buy, and if we buy 5 boxes of pasta as indicated in panel A, then we'll buy 18 pounds of steak, spending a total of $180 and leaving us with $20 to spend on all other goods. If we spend it only on pasta, at $4 a box, that'll allow us to buy the 5 boxes indicated in panel A. We can then again translate bundles A and B onto the lower graph, where we put income on the vertical axis, but we leave pounds of steak on the horizontal axis. At bundle A, we have an income of $100. Therefore, bundle A again occurs at a vertical height of 100, and it indicates that we'll buy 6 pounds of steak at that income level. Bundle B occurs on the magenta budget constraint, which corresponds to an income level of $200. It therefore occurs at a vertical height of 200 in the lower panel, and it tells us that we'll buy 18 pounds of steak at that $200 income. By connecting A and B in the lower panel, we're then estimating the shape of our income demand curve for pounds of steak. This demand curve is now upward sloping, which means that as income rises, we'll buy more steak. In other words, steak is a normal good, whereas pasta in panel A was an inferior good and therefore had a downward sloping income demand curve. It should make sense that income demand curves for inferior goods slope down and income demand curves for normal goods slope up. There's also an in-between case, the case where the income demand curve is perfectly vertical. That case represents the borderline case between normal and inferior goods, which we called quasi-linear in Chapter 7. Thus, if a good is quasi-linear, its income demand curve is perfectly vertical. One final quick note. Many textbooks refer to income demand curves as angle curves. So if you ever see the term angle curves, all it means is an income demand curve, in other words, a curve that illustrates the demand for a particular good as income changes and all other economic variables such as prices are held fixed.